1, 2, 3.
What's up, team? Today we're going to factor some quadratics where the a value is not 1. So, as a reminder, all quadratics are always in the form ax squared plus bx plus c. C is our constant, the a is attached to the x squared term, and the b is attached to that middle x with no exponent here. We have factored a bunch of these where the a value is 1. We know that we're looking for two terms that multiply to your c, add up to your b. Well, what if we have something like this? We have 3x squared plus 5x plus 2. The trick is not quite as easy. It's not quite as simple as figuring out what multiplies to 2 but adds it to 5, because that 3 really throws a wrinkle into things when we get our FOIL on and whatnot. So the way that we're going to do this is there is a little bit of guess and check. What I did with both of these is I picked ones where I actually don't know the answer to on purpose. So you're going to see me guess, you're going to see me check. I'm going to do my best to explain my reasoning as I do this. And hopefully this works. Otherwise, I don't know, I'll have to try this again to make another video or something. So the way that I like to approach these ones is using a visual method. I call it the box method. It's really just using the same idea like a Punnett square in science class, where, say, you have a square and this is like x and 2 and x and 5 or something. You multiply the terms together where they meet in the box. So this would be x squared, this would be 2x, this would be 5x, and 5 times 2 is 10. So we're going to use that idea, but we're going to start with what's in the middle and try to find the stuff on the outside. So with this one here, 3x squared plus 5x plus 2, I'm going to start by creating a box. And I'm going to fill in a few pieces that I know. I know in this top corner, I'm going to occupy it with 3x squared. And on the bottom right, I'm going to put my 2. The reason why I know those things are true is because whatever I end up with on the outside here, the x terms are going to multiply together. Something x times something x is going to be 3x squared. And then my constants that are going to be multiplied together are going to multiply up to 2. The two empty boxes, well, these are going to be the x's before we combine like terms. And we need to figure out what they are. We don't know what they are, but we know they add up to 5x. So that kind of idea is still true, the same as when we factored quadratics previously. So this is where we kind of get our guess and check on. It's an educated guess and check, but guess and check nonetheless. So we need to think of two terms that multiply together to be 3x squared. So for example, maybe it's x and 3x, because 3x times x is 3x squared. Okay, now we need two numbers, two constants, that are going to multiply to 2. But there's a trick to it, because it's not going to be as simple necessarily as 2 and 1, because where does the 2 go, where does the 1 go? So we got to be thoughtful about it, because these two terms that we create, something x times something else x, or something x and something else x, they have to add up to 5x. So, let's see what we can do here. If I put like I think I see it. So what if I did like a 2 here and a 1 here? Well, 2 times 1 is 2, so that works. And let's fill in the other boxes and see what happens. I'll change colors. Let's go green. X times 1 is x. 3x times 2 is 6x. Oh, yikes. I didn't get it right. Because 6x plus 1x is not 5x. So this is not the correct solution here. What if we switch them up, though? What if, instead of the 2 down here and the 1 up here, we put the 2 up here and the 1 down here? Let's see what happens. 2 times x is 2x. 3x times 1 is 3x. There we go. There we have it. 2x plus 3x is our 5x. So in factored form, we would say that this is going to be 3x plus 2 times x plus 1. So this is it. This is what it looks like in FOIL form. This is how we unfoiled, as it were, this quadratic here. If you're not convinced and you want to check the answer, just FOIL this. 3x times x here is 3x squared. The outer terms, 3x times 1. The inner terms, the last terms, combined like terms, 3x squared plus 5x plus 2, boom, that's what we started with. So the box here is kind of just a visual method to see just a different way to look at it. It helps me, maybe it doesn't help you. Maybe you don't like the box method. Maybe you want to jump to something kind of like this and just guess and check that way. Cool, that's fine. That works for me. Pick the way that works best. I recommend the box because it's an easy way to kind of organize and see what's what. Okay, let's do a second one. Again, I don't know how this one factors. We're going to figure it out together. So I'm going to create my box. Top, I'm going to put 4x squared from right here. The bottom right, I'm going to put my 21. Now, some options with this one. Because 4x squared can split up multiple ways. There can be 4x and x. We can do 2x and 2x. Let's see. One thing I am pretty sure about here is the 21. I'm pretty sure it's going to be, oh geez, it could be 7 and 3. It could be 1 and 21. Ooh, I think it's going to be 7 and 3. Let's check it out. But I know that we're going to multiply to a negative number. So I'm just going to try -7 and -3 because they multiply to 21. I chose negatives because we're going to end up with a negative b value here. And if I do 2x and 2x, is that going to work? They multiply to this, but I end up with a -14x here and a -6x. Oh, that one worked. First try. Got lucky. That's not normally the case. A lot of times it'll take 2 or 3 tries. But -6x minus 14x is indeed -20x. So to factor this quadratic, we would say to unfoil it, we'd say it's 2x minus 3 times 2x minus 7. And again, if you're not convinced, you could FOIL it, just like we did a minute ago with this one, and you'd end up right where we started. Okay, this is how we factor quadratics with an a value that is not equal to 1. Go ahead, give these practice problems a go. I have some solutions posted, and let me know if you have some more questions.